Hi everyone, now we are going to start with the finite automata, which is the type 3 grammar, and the language used is known as regular language. Now, as we have studied in STLD subject, FSM, finite state machine, it is the simplest kind of language recognizing machine. That is, we provide it a string as an input and it gives an output. Now, what we are studying here is DFA and NDFA, wherein either the string is accepted or rejected. Now we use a transition graphs like this to represent the machine, wherein we have some states like Q0, Q1 and Q2 and transitions between them, which is like going from Q0 to Q1 and then Q1 to Q2. These A and B are the inputs. Now an automation in the form of FSM is known as finite automata. Now the question arises, why are we studying it? Because if we have a string of infinite length like of this type, then on using this machine, our process can be done more efficiently automatically rather than manually. So, and the next benefit is that if I am providing you infinite number of strings, then rather than doing manually, we can accomplish this process more efficiently by using these machines. Next is the now we are defining the FSM, which is a 5 tuple structure and represented by any machine M, which has these 5 parameters, which is Q, sigma, Q naught, delta and F. The Q is the finite set of states, which in the previous example here I can show you is Q0, Q1 and Q2. And sigma is the set of input symbols, which is the alphabet like those A and B, which were the inputs. Next is Q0. It is the starting state which belongs to the Q, which is the finite set of states. Next is delta. It is a transition function, and like I can write this transition function for this previous example when my initial state is Q and the input is A, which gives me the next state Q1, which can be represented by Q0 A gives Q1. Next is the F, which is the set of desirable final state, which also belongs to Q, like Q0. Now my finals actually the final state are represented by two concentric circles, like we can see here. This is my states Q and this is my state Q0. Now my final state is represented by two concentric circles. Now, as I told you in the previous video, finite automata is of two types, with output and without output, and these acceptors are of two types, DFA and NDFA. These differ by the transition function delta, but they have the same method of identifying whether a string is acceptable or not. These both are of same 5 tuple structure. So let's start with the DFA. It is a machine in which transition from each state is defined, and the transition function is defined by this. The transition functions are very important and you should understand them carefully. This is the transition function Q when multiplied with the set of alphabet gives us Q, like this Q0 belongs to Q, E is the set of inputs, and this gives us the next state. So present input and with the input combined gives us the next state Q1. So in a DFA we have finite number of next state from present state. Suppose I have 5 input, that gives me sigma alphabet set of 5 symbols. Then if I am on any state that I have the 5 next state corresponding to the 5 inputs. So if I have a 2 input, then I would definitely have 2 finite next state corresponding to those 2 inputs. Now let's understand DFA with a question. If I'm given a question using DFA, design a transition diagram for a machine with alphabet set AB accepting strings starting with A. That is, this machine should accept any of the strings which start with the letter symbol A. Now, before doing the question, you must understand this, that multiple DFAs could be generated for a particular problem, but we choose that DFA which has minimum number of states and less transition between those states, and we have many algorithms to minimize particular DFA. Now, coming back to this problem, we have to make a machine which can accept a string starting with A. So this is the initial state. It is represented by an arrow which is not coming from any other state. And then let's consider a string A. Then it should be accepted by the machine. So if I'm on my initial state, I start from the left of the string and take this character as input. Then that gives me A. So now I come to the state Q1, but my string ends here. This means that this state Q1 must be my final state. So I have to mark it with a double circle. So now I make it. So for this string A, this is the correct machine. But as I said, a DFA has states which give the next states for the inputs. So if I'm on Q1, I must provide the next state for the inputs A and B. So my string which starts with A should end on this state, final state only, so that at last I can accept that string. And coming back onto Q2, if a string like BAB is encountered, I must be on this state only, as the string can't be accepted. So this A and B can be put here. Now the states like Q2 are called dead states because you can't go from this state on reaching this state. I mean, you can't leave it. When you have come here, you must remain here. So I can simply remove it and write D over here. This D represents the dead state. Let's check with example like string ABAB. My string starts from here. I am on the state Q0. I get the input as A. I come here. Then I get the input as B. I am back to the state. Then I get A. I'm back on this state, and B back on this state. So at last I am on a final state. So my string will be accepted. But if my string is something like this, BAB, I start from this state, come here, back onto this state when A is encountered, and back on this stage when B is encountered. So my final state is not one of those desired final states which can be accepted. So therefore this string will be accepted while this won't be accepted. In the next video we will be discussing NDFA and various questions which will be solved with both DFA and NDFA. Thank you.